Okay, let's look at a couple of counting problems involving a checkerboard. And this checker sitting in front of us here in a rather boring checker game. And nonetheless, we're going to try to count the number of paths that this checker has to get to the top row, the back row on the checkerboard, where it could potentially become kinged in an actual game with some more pieces involved, hopefully. So we're assuming that checker piece can only, or that checker can only move diagonally. So if that's the case, there's only one path that checker can take to any of those squares on the checkerboard. And once we establish that and look for diagonal movement of any of those ones, we can start to see our Pascal triangle taking shape. And we almost have an entire fourth row there, but of course our checkerboard, we're running out of space on the very left. So after this row of counting, things get a little more interesting. So this square, the only paths into this leftmost square, and I guess that second row from the top where the arrow is pointing to there, are only those four paths up until that yellow arrow. And then after that, it's just business as usual, counting your Pascal numbers. And then similarly, that 5 is the only number that can flow into that top right corner. And then we fill in the rest with our Pascal method of counting, and we have all those total number of paths that checker has to get to that, I guess, king me row. And our final answer would be 14 plus 20, 15 and 5, or 54 possible paths to get kinged. Okay, and our last example, a little bit more exciting, but again, not really an authentic checker situation. This black checker, again, is going to try to get kinged, but it's also going to try to jump over that white checker along the way. So that limits that black checker's motion a little bit, or its movement. So it can start to move diagonally. And notice I stopped a little bit earlier because I still have to keep in mind that that checker has to double back and jump the white checker. So that means I can't go all the way, I guess, to the very left and the very right of the board, because then there'd be no way I could jump the white checker. So if we understand that, then we can start to do some Pascal counting. We get our 3s, and then we reach, I guess, the most difficult part of this question is, what do we do after this? Well, if you understand we're trying to jump that white checker, it's probably not too difficult. Just make sure you know that those 3 paths have to jump over that white checker, or these 3 paths could also jump over that white checker. And now we're in the home stretch. Those 3s can keep going and follow into, I guess, diagonally to the king me location of that uppermost row in the checkerboard, and of course the 2 red 3s add together to give us 6. Okay, so with that limited motion, the black checker only has 3 plus 6 plus 3, or 12 possible paths to get to the king me row, that uppermost row in our checkerboard in front of us. And of course it also passes over or jumps that white checker along the way.